Are there any other potential examples of or real world examples that you could also refer to that where you would need reinforcement learning, specifically in industries, if you can think of any?
Yeah, so I think reinforcement learning, because it's so different, it's one of those techniques that hasn't seen that many or industry applications yet. And I think I very much focus on the yet there. So I think I'll just take it back to the types of problems that I think reinforcement learning is really well suited to try and solve. And to me, that always falls within the almost control system type of domain, right? So let's take it again one slight step further backwards as to sort of how does reinforcement learning actually work, get into the nuts and bolts a little bit, and then see why is it suited to sort of that control type of environment. So I've already mentioned it's not strictly like supervised learning where we've got some examples with known targets and we just need to find the correct mapping within the data, sort of find these relationships that most accurately link our sort of sample variables to these targets, and then we're good to go. So supervised, we know exactly what we want, we've got some samples, and then we can go. And then the issue mostly is labeling data and finding sort of the correct targets for our inputs that we have. Then we have unsupervised learning, which is sort of more on the clustering side generally, where we just want to find structure in sort of unstructured data. So let's say, for example, we're looking at a recommendation system. So I'm browsing on Takealot or on Amazon or wherever, and I'm looking at certain products, and they can see, okay, I'm looking at these products. Pierre, you also looked at this product, and then you went and purchased that product. Now, because we've been looking at similar products, they find that structure in the data, and then they link us as similar customers, and they say, we are similar. There's no direct target, but then because we are similar, they're going to show me products that you perhaps have also purchased. So that's sort of the unsupervised side of things. And then reinforcement learning almost falls somewhere in between there. And it always has this feedback loop. So in general, in reinforcement learning, there's an agent, and that's generally the computer that tries to learn. And this agent works within some other environment. As we are living in an environment now, we just place that agent into that environment. And in the traffic simulation case, the simulation model acted as the environment. Reinforcement learning has been really popular in gaming, and it's done really, really well with games. So, for example, when you have a computer learning to play chess, the chessboard is the environment, and there are strict rules and there are things governing that environment, and the agent interacts with that environment. Then we encode a goal for the agent to strive towards. So playing chess, the agent should win the game of chess, naturally, quite easy. In traffic flow, we want to find that optimal point of traffic flow. We want to get as many vehicles going along that highway as possible. That's what we're striving to. So we give the agent this goal, and then the agent can perform certain actions. And let's say we're looking at the highway example again. The agent can go and it can reduce the speed limit, for example. See what happens. This action changes something in the environment, and there's a response. And then based on that response, the agent gets feedback based on the action that it took to say, yes, this action moved me closer to my target. Oh, no, I'm actually further away. And then it initially tries these actions randomly to get to a point. I don't know anything. I need to first figure out what's going to get me closer to the goal, what's going to get me further away. And then as you sort of build up this knowledge slowly, you can say, I'm going to start exploiting what I've already learned. So then you're saying, okay, I've been in this sort of situation before. I know this works. I'm gonna do that again. So quite similar to the way that humans learn. I mean, when you're a little kid, you touch a hot plate, you're like, ow, that's hot. I shouldn't do that again. Exactly. So you get some negative feedback that hurts. Don't do that again. Same sort of thing. So we need to encode this feedback signal that the agent gets that sort of then basically encodes this sort of new state of the environment saying, is this favorable or not? Am I moving in the right direction? Yes or no? And that's sort of the main thinking. And that's sort of, because we're always working in this loop, we're always going action, change in the environment, next action, change in the environment, feedback with the next action. And then we always keep going through this. So that's why it's sort of really well suited to these control types of problems. So some applications that I have seen or that I've heard of was that Google actually started using reinforcement learning for the cooling in their data centers. So instead of having just the traditional control system, which would have a temperature regulator, they actually put a reinforcement learning agent on this to try and really, in their case, the focus was on energy consumption. So they want to minimize the energy consumption while maintaining sort of process limits and making sure that these computers that are in the data center are cooled to the right temperature without failing and so forth. And they were actually eventually able to achieve some quite significant reductions in the total cost that it took that was required in order to keep those computers cool. So that was sort of one real world application that I saw. Another one that is often referenced, but that's sort of within a gray area generally, is that of autonomous vehicles, sort of self-driving vehicles, right? So again, classic type of control problem. You've got some camera feeds and sensor feeds coming in. That's the state of the environment. The vehicle knows I need to stick within the lanes and I shouldn't bump into the car in front of me. But then you need to sort of find this control to go around the corner, how much steering input is needed, how much braking. That's sort of another classic use case. And I know that because I actually had a look around for after my doctoral studies, sort of I know that Bosch, for example, in Germany, they're developing such systems specifically with reinforcement learning in mind. And I think that's sort of the real thing where it's going to come to the fore and where it's going to shine.